I'm Anil Kumar. Welcome to my series on logarithms. We are sharing some very interesting questions based on logarithms in this playlist. I hope you will enjoy this and learn from the given examples. Most of the questions have been taken from previous test papers. The question here is, square ABCD has area 36 and AB is parallel to x-axis. Vertices A, B, C are on the graph of y equals to log to the base ax, y equals to 2 log ax, and y equals to 3 log to the base ax, respectively. What is A? Find vertices of the square. You can always pause the video, answer the question, and then look into my suggestions. Let's tackle the problem one by one. We are given a square, so we know there is a square ABCD. Area of the square is 36 unit square, right? Let's say unit square. So that means each side length will be how much? So sides of 6 units, correct? Now we are also given that these points lie on the graph of these logarithmic functions. So let's try to analyze. So let's say log functions basically are always increasing. They're kind of like this. Let me just sketch 3 logarithm and then we'll work further on it, right? So we have, let's say that is our log to the base ax, then we have vertically stretched it and got the second graph, and then if we stretch it further we get the third graph, correct? So these are the 3 logarithmic graphs. The points are on these graphs. We have to form a square, and we are also given that AB is parallel to x-axis. Vertices A and B lie on the first 2 graphs, right? So the vertices A and B are somewhere here. Let us say like this. So if we have to make a square, we have to go up. Third vertex C is on the graph of the third function, vertically stretched by 3. So third vertex will be kind of here, right? So more or less, we got a square here. So definitely this is an approximate diagram, right? So we do form a square. In this square, the point A is on graph of log to the base ax, B is on 2 times log of x, and C is on 3 times log of x, correct? So let me rewrite. So the first graph on the top here is log to the base, A 3 times x. The second graph here is 2 times log to the base A of x, and the first one here shown is log to the base ax, correct? So these are the 3 graphs, and that is the square. Now since the diagram is very clear to us, it is simpler to answer this question. You can now pause the video and answer it. So we can begin with this horizontal line AB. So what we see is that y value is same for A and B, correct? Since that is a horizontal line. So that means that we can equate log to the base A of x to 2 times log to the base A of x and find the x value, right? In fact, this point here is not at x. This is at x plus 6, right? It is as x plus 6. Since A and x we have found are 6 units away, right? So let me rewrite here. AB, the distance is 6. So if I'm using a point x here, then at A we have x plus 6. Is that correct? Right. So therefore we put x plus 6 here, the x value, but the y values are same. Does it make sense to you? So that is how you get your equation. Now that means that x plus 6 is equal to, this is x squared, right? X to the power of 2, which we could write this as log to the base a of x squared using the power rule. And so x plus 6 is equal to x squared. Now that is a quadratic equation which we can solve. So we have x squared minus x minus 6 equals to 0. And this can be factored. We can write this as x minus 3 times x plus 2 equals to 0. And that gives you two values of x. X equals to 3, OH is moving right, and that is what we need. Now, in our function, x has to be greater than 0, so that becomes the right value. We know this is not permitted. So x equals to minus 2 is not permitted. Since in this function, x has to be greater than 0, correct? Since log to the base ax. So we cannot take a negative value. So we have found a value for x at least, x equals to 3. Now we need to find the base a, correct? For the base, what we could do here is we could equate the y values for these two. So as you can see, for the same x value, difference of y value. For the point B and C, I should write C and B, is 6, correct? So that means y value means we are looking at points where x value is same, right? So we can say that 3 times log to the base a of x minus 2 times log to the base a of x is equal to this difference, which is 6 units. Is that clear to you? Right? So we get our second equation. We know what x is. We can always find what a is, right? So from here, we get log a x cubed minus log a x squared equals to 6. Now, using the logarithmic rules, we get log to the base a of x cubed over x squared equals to 6, correct? So that means a to the power of 6 is x, right? So that gives us a to the power of 6 is x cubed over x squared, which is x. We know x is 3, right? So a is equal to x to the power of 1 over 6. And since x is 3, it is 3 to the power of 1 over 6. Perfect. So we have finally found that for the given function, a is equal to 3 to the power of 1 over 6. So that is the answer for the first part. Now we need to figure out what are the values of these vertices A, B, and C, right? And we know the x value is 3. So let's work out the vertices on a fresh page. So once again, let us first draw the figure. So I'm making the square slightly bigger this time. And we'll find the vertices A, B, and C. The graph was such that this point A was on log to the base ax. The second point was on the graph of 2 times this value, and the third point here was on the graph of 3 times log ax, right? So this is the graph of y equals to 3 log to the base ax. Here we have the graph of y equals to 2 log to the base ax, and the basic function here is y equals to log to the base ax, correct? So we need to find the points. The points were given as A, B, and C. So let's figure out the point B first, right? So the point B will be what? Here, the x value is equal to 3, right? So we need to work out y is equal to 2 times log to the base a, and we know a is 3 to the power of 1 over 6, correct? So a is 3 to the power of 1 over 6, and the value of x is 3. So that is the value of y at b. Since b corresponds to the graph of function y equals to 2 log to the base ax, this one, right? So that's the point which we are trying to figure out, the y value. Okay, so from here we can say y equals to 2 times. Now let's change the base, right? So we get log. So we can write this to the base of 3 divided by log to the base 3 of 3 to the power of 1 over 6. Good. So that gives you the y value as 2 times log 3 of 3 is 1, and here we get 3 to the power of 1 over 6 as 1 over 6. So that gives us the value of 6 times 2, which is 12. So the y value here is 12, and therefore the point B will be, for us, x is 3, so we have 3, 12. Is that clear to you? The point A is 6 units to the right, and therefore point A should be 6 plus 3, which is 9, the y value being 12 itself. The point C is 6 units up, right? We know that this distance for us is 6. This is also 6, correct? So for the same x value, point C is x value is 3 and the y value 6 more than 12, that makes us 18. And from here we can say point D should be 9, 18. Does it make sense? So these are the vertices. But as a practice question, what I would like you to do here is also calculate the value for the value for A, right? We know that point A will be at x plus 6, which is 9. So we can substitute this here. So y value will be equals to log to the base A, which is 3 to the power of 1 over 6 of 9, correct? So you can find this value. So change of base you can again apply just for practice, right? 3 square is 9. And here we get log to the base 3 of 3 to the power of 1 over 6. So that gives you 2 over 1 over 6. And that is equal to 2 times 6, which is equal to 12. And so you get the same y values. Does it make sense to you? Right. So therefore the coordinates of A will be 9, 12, right, as we had seen here. So you can use the same method, change of base formula, and then calculate the values for points C and D also. And the logic, since these are the points on the square as we worked out, we could directly get the 4 points as shown here. So I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.